falling into a black hole, you have less than 60 seconds left. Not because you're running out of air, because time itself is about to stop behaving the way you think it does. You're in a ship, falling toward a black hole 20 times the mass of our sun. From out here, it looks calm, silent. A perfect circle of nothing, rimmed by a ring of superheated light gas and dust screaming around it at a fraction of the speed of light before it disappears forever. It looks peaceful. It is not. Gravity isn't pulling you inward. It's pulling the future away from you. Here's the first thing nobody tells you. You won't feel yourself falling. Free fall feels like weightlessness, like floating. Your body, your instruments, your coffee cup drifting beside you, all falling together, all silent, all calm. But that's not the terrifying part. The terrifying part is what's happening to the light leaving your ship. Every 7 seconds, you send a signal back to Earth. Your crew's mission control watches your clock tick slower, and slower, and slower. Not because your clock is broken, because time itself is bending around you, stretched thin by gravity so extreme that it warps the fabric of space. To them, you're freezing. To you, everything feels normal. This is where physics has another surprise. As you approach what's called the event horizon, the invisible boundary past which nothing, not even light, can escape, something strange happens to the black hole itself. It disappears. Not because it's gone. Because you're crossing into a region where the very language of distance and direction stops applying the way it does out here. Cross it, and the universe loses the ability to tell your story. To an outside observer, you never actually finish falling in. Your image just fades, redder and dimmer, frozen at the edge, forever. But for you, inside your ship, inside your own experience, nothing marks the crossing. No wall, no flash, no warning sign. You pass through the point of no return without ever feeling it happen. The universe doesn't hate you. It simply doesn't know you exist. Then something impossible begins. Depending on the size of the black hole, gravity starts pulling harder on your feet than on your head, because your feet are just slightly closer to the center. For a small, stellar mass black hole like this one, that difference is catastrophic. Scientists call it spaghettification. Your body stretches thread by thread until you're a ribbon of matter or a mile long and an atom wide. This isn't science fiction. It's a direct, tested consequence of Einstein's general relativity, the same theory that keeps your GPs accurate to the meter. But for a supermassive black hole, the kind sitting at the center of our own galaxy, 4 million times the mass of the sun, the math flips. The gravitational gradient is so gentle, you could cross the horizon of a giant like that without feeling anything at all. You could fall in gently, painlessly, and never know the exact moment you left the observable universe behind. That's where scientists stop having answers. Because what waits at the center isn't a place, it's a mathematical scream. General relativity predicts a singularity, a point where density becomes infinite, where space and time stop making sense, where the equations that describe reality simply break. Physicists don't think this is literally true. They think it's a sign that we're missing something, a theory that unites gravity with quantum mechanics. One that could replace that infinite point with something we don't have the words for yet. Nobody has ever tested it. Nobody has ever confirmed what it actually is. A black hole doesn't destroy reality. It exposes its limits. And here's where it gets even stranger. Inside the event horizon, the roles of space and time trade places. Falling toward the singularity stops being a direction you can choose to avoid it, becomes a direction in time. Moving toward the center becomes as unavoidable as tomorrow. You can no more resist it than you can resist getting older. The closer you get to truth, the quieter physics becomes. There's a theory still unproven, still debated that at the horizon, instead of a smooth crossing, you'd hit a wall of pure, scrambled energy. Physicists call it the firewall paradox. It suggests something is deeply wrong with how we understand information, gravity, and quantum theory all at once. Nobody knows which picture is correct, the gentle fall or the wall of fire. That contradiction has haunted theoretical physics for over a decade, and it's still unsolved. The greatest mystery isn't what's inside. It's why the universe refuses to answer. Somewhere in that darkness, everything that ever fell in every star, every planet, every photon of light is still in some form encoded. In 2019, the Event Horizon Telescope gave humanity its first real image of a black hole shadow. In 2022, it showed us Sagittarius A, the giant sleeping at the heart of our own galaxy. We have seen the edge. We have never seen and may never see what lies beyond it. Maybe the greatest mystery isn't what's inside a black hole. Maybe it's why the universe never intended us to know. Gravity isn't just a force. Out here at the edge of a dying star's collapse, it's a boundary between what can be known and what can only be imagined. If black holes feel like the edge of understanding, wait until you find out what, if anything, existed before the Big Bang. Some physicists think the answer isn't nothing. It's something far stranger. What if the universe was never built to be understood?